Hello, welcome back. We're going to take a day just to discuss what's called the natural log or the natural base E log, and it's denoted as ln of x. We call it lnx, and it's actually log base E of the input x. But instead of writing LOGE, we write LN and we don't write the base at all, okay? So we're going to learn how to solve logs that use this natural base E. All right, so remember that when we had log x, you're going to hear a little motor in the background. That's my neighbors. We were in base 10. It didn't say base 10, but we understood that we were in base 10. When we were in log base 3 of the input x, well, that was base 3. And so the natural log, ln x, is the log associated with base e. It might be helpful if you just, in the beginning, till you get used to it, use a little e there. So if we wanted to exponentiate this, we could say that my input x is equal to my base e raised to the power of y. All of the log properties apply to natural log base e. We can solve by exponentiation. The hardest thing to remember is that our base is e. We can solve equations by using the equality property of logs, setting inputs equal to each other. We can solve inequalities by using the inequality property of logs, by using the same inequality symbol between our inputs, always keeping in mind a lower limit might be required. We can expand and condense natural logs in base E the same way we did with other logs, base 10 and other logs. So the zero property of logs, of the natural log, says the same thing, that the natural log base E of the number 1 is equal to 0, and that is because my input 1 will always equal any base, which is here E, raised to the 0 power. The identity property of logs says that the natural log of base E of the input E equals 1, and that's because my input E will equal E to the first power. My negative identity property of logs says that the natural log of base E of my input 1 over E has to equal negative 1, and that's because 1 over E equals my base E raised to the negative 1 power. The inverse property of logs says that the natural log in base E of the number of the input e to the x equals x. And that has the same property that we used before for others, the same as the inverse property of exponentials. And then the product property, if I have the natural base log, the natural log of base E, I'm used to calling it just ln, so I'm trying to be very specific for you, of the product of the inputs m times n, then I can rewrite it as the sum, and I use the natural log of base E of the input m plus the natural log of base E of the input n. My quotient property works the same way. The natural log base E of m over n equals the natural log base E of m minus the natural log base E of n, and the power property is the natural log base E of x to the nth is equal to n times the natural log base E of x. So let's get down to it and let's just start working this. We need to simplify. So one of the things you need to get used to seeing, and it happens a lot, is this ln E, and you want to recognize that anytime you see ln E, it always simplifies to 1. So that's 2/3 times 1. So that's just 2/3. So that simplifies to 2/3. Okay. The natural log base E of the input e to the 2x. Well, this is just 2x because I moved that forward. This becomes 1, so I get 2x times 1, so that equals 2x. Okay? A little weird at first because we're used to seeing, well, log, and we're used to seeing a base other than the common log of base 10. Okay? We can write in exponential form as well. So remember that we're in base e. So whenever we write in exponential form, my input will always equal my base raised to my exponent. You just have to remember where you locate the base, where you locate the input, and where you locate the exponent. It's all the same places. Okay. Number 2, the natural log base e of the input 25 is greater than y, so we know that my input 25 has to be greater than my base e raised to the y power. Okay, that would be how you would exponentiate it. We can also condense to a single log, and all of these things are leading us to solving. My coefficient here can be raised to the power, so I have the natural log of 10 cubed minus the natural log of 8. So this would be the natural log base e of 1,000 divided by 8. So that's the natural log of 125. You could go further and say that that's 5 cubed, and this is sufficient. We could go the natural log of 5 cubed, and that would equal 3 times the natural log of 5. This would be its most simplified, and this would be its condensed version. And number 2, we would have the natural log base e of 40 plus 2 times the natural log base e of 1/2 plus the natural log base e of x. They're all being added, so everything's going to be multiplied together. So I'm going to lift my power up first. This coefficient I'm going to lift first. So I'm going to write natural log of 40 plus the natural log of 1/2 squared plus the natural log of x. I'm going to apply that property, that power. So I have ln of 40. There it comes, ln. That's what I'm used to calling it, so sorry. Plus the natural log base e of 1/2. Whoops, that's a 4th. When I square it, that's a 4th. Plus the natural log base e of x, the input x. I'm just going to multiply all of those inputs together, and I get 40 times 1/4 times x, so I get the natural log of 10x. I would call it ln 10x, natural log 10x. And it takes us to solving. Okay, so the same ideas apply. If you have a single log and it's isolated, then the first thing you want to do is exponentiate. The thing you have to remember is that you're in base e. So to exponentiate, this says that my input, 2x, has to equal e cubed. Okay? To solve for x, I'm going to divide both sides by 2, so I get x equals e cubed over 2. This is your exact solution. For an exact solution, you would leave it in terms of e. You would not convert it to a decimal approximation. Then the next instruction says state the decimal approximation to 3 decimal places. So when we plug that into our calculator, we get, oh, hold on, I gotta get my right page here. Sorry about that. .043. So x is approximately equal to 10.043. You would take e cubed and divide it by 2. So on your calculator, you would go second e to the x, square it, or cube it, close that off, divided by 2, and you get 10.0427. So we would round that to the third place. It would be .043. This next one, notice that we have a -3 on the same side as my natural log base e. Notice that the -3 is not part of the input because it is not inside the parentheses there. So I'm going to move it first, and I get natural log base e of the input 5x has to be greater than, I'm going to add 3 to both sides, and I get it's greater than 1. So now I'm going to exponentiate because I have a single log. So this would be my input 5x has to be greater than e to the first, or just e. I just hate that little line thing that happens. Okay. Now to solve that, I am going to divide both sides by 5. So I get e over 5. Here's my exact solution, e divided by 5, and then to get a decimal approximation, I use my calculator. Second, e to the x, 1. You have to put that in as a 1, and then enter, divided by 5, and you get 0.5436, so that would be x has to be greater than 0.544. All right, very good. This log equation, notice that we have the natural log base e on both sides of the equal sign. So that means that we get to use the equality property of logs, and it says that my two inputs have to be the same, right? So that means x minus 4 squared. Oh, I just don't like that. X minus 4 squared has to equal 2x, right? So I'm going to square my quadratic and get x squared minus 8x plus 16. I just FOILed it. I can do that in my head. If you need to write it out, you should. You should hit pause and take the time to FOIL this. All right, do it the long way if you need to. If you can learn the shortcuts, that's all the better. Less time for you in class, okay? Is equal to, back down here, 2x. I'm going to move my 2x over. So I get x squared minus 10x plus 16 is equal to 0. You can use the quadratic formula on this. I like to factor, so I would opt for factoring. So I would write this as x squared minus 8x plus negative 2x plus 16 equals 0. I would group and factor out the common factor. And then I would get x minus 2 as a factor and x minus 8 as a factor. And then when I solve those, I would get 2 and 8. Okay, and so we have to plug them in and check them. If I plug in a 2, notice that I get in parentheses negative 2 over here, right? But I'm squaring it before I'm taking the natural log, so I'm okay, all right? And then, so that gives me ln of 4, and then my other side would be ln of 2 times 2 is 4. So the 2 works, okay? And the 8 also works. 8 minus 4 is 4. 4 squared is 16. So on the left, I get ln of 16. And then on the right, I would get ln of 16. So that one works too. All right? Okay. And I believe that takes us to the end. Yep. So I hope you did well on the video questions. Remember that if you got anything wrong, please write down what you did and what your question is, and then I can answer it for you when I come around and talk with you tomorrow. Thanks for listening. I'll see you tomorrow.